Alright. So let's look at this question. It's NCAA tournament time, baby! Alright. So Dick Vitale claims that the average college basketball player is over 76 inches. What do you conclude about this claim from your sample of 40 players with X bar equal to 77, and let's take sigma to be 2 inches. Alright, so how do we do this problem? So the first thing that you should be saying to yourself is, I recognize that this is a hypothesis, I recognize that this is a hypothesis test question. So when you have a hypothesis test question that's got a claim in it, the first thing you should do is write down your claim in notation. What's the claim?
Average basketball player is over 76.
Right. The claim is the average basketball player is over 76 inches. Now how do we write that down in notation? Okay. So the mean is greater than 76. Now the question is which mean? What's the notation for it? P is for what? Oh, is this a proportion? Is this about proportions? No, this is about means. Okay. That's the first thing. Whatever. Okay. So what do we do? Well, is he claiming that the average college basketball player from a sample is over 76, or the average college basketball player, the whole population? This is a claim about a population. So this is a claim about mu. He's making this. He's saying when you say the average college basketball player, are you talking about a couple? Or are you talking about all of them? That mean in English that means all college basketball players. So he's talking about all of them. So he's talking about the population. So population mean is mu. Now when we do a hypothesis test, we have to write down two hypotheses. So then the thing you have to recognize is that, is this HO or H1? This is H1 because when you write down HO, when you write down H1, HO, how do you always write it? HO is always equals. See, now it's easy. Now you can see why we always use equals for HO. It makes things a little bit easier. So HO is going to be mu equals 76. So far this is just notation.
But in this case, it will be greater because H1.
But we write down both. Okay. So this is this. Okay. So now that we've got this, what's the next thing we do? We can't draw the picture yet. Yeah. We have to analyze the distribution first. So how do we do that? When we talk about a distribution, what are the things that we have to write down? Yeah. Mu, but not just mu. You said mu for p hat. Is this question about p hat? Mu for what? P assumes we're talking about proportions. Mu for x bar. This problem is about x bar. As Stephanie said, it's right there. Okay. So mu for x bar. What is mu for x bar in this problem? No. Mu for x bar is the same as mu. And what's mu? 76. Next, what do we have to figure out? Sigma x bar. Now what is sigma for x bar? How do we figure that out?
40. No, actually, it would be
Nope. How do you find sigma for x bar? Right. So this is 2 divided by, what's n? 40. Okay. So now we have to work this out. So this equals 2 divided by the square root of 40. 0.3162. And then what do we have to ask? Alright. So is it normal? There you go. This is a problem about means. So when the problem is about means, what do you have to check to see if it's normal? There you go. Yes. N is at least 30. So we're good. Remember that the test is different if you're dealing with means or you're dealing with proportions. Okay. So now what can we do? Now we can draw the picture. Alright, so what goes on the picture? 0 in the middle for z. What else? X bar, and how do we label here? 76 goes where? And then what else do we label? What other value do we have? We have 77 for x bar, so we label that. Now where do we shade? To the right of what? We shade to the right of 77. Now I know the claim says over 76, so you figure we shade to the right of 76. Let me just point out that doesn't make any sense, because if we shade to the right of 76, what's the area going to be? 0. No, it's going to be half. It's going to be 0.5. So that doesn't tell us anything interesting. What we're looking for is it too much over 76? That's the question. So we shade starting at... I can't really explain it in a clear way. Let's just say shading from 77 is the thing that makes sense. Okay. So now what do we do?
Now we
Find the z-score. So 77 minus 76 divided by? No. Divided by 0.3162. And that is 1 over 0.3162. That gives you 3.1626. So that's the z-score. We fill that in. And now what do we do? Now we have to find the area. Okay. So you get norm S dist of 3.1626, and that gives 0.9992. So that also gives you an area in the tail of 0.0008. So here comes the final step in a hypothesis test question. What do you do? Okay. So, if mu equals 76, then the probability that x bar is 77 inches or more is 0.0008. Would you say that that's likely or unlikely?
Unlikely.
That's very unlikely.
What would you say is likely?
Well, I'm going to show you how to write it down for real now. So, knowing that, here's how we state our conclusion. So probably mu is greater than 76, right? It's probably not equal to 76, it's probably greater than 76. how likely is it that it's greater than 76? Very likely. How likely? Yeah, exactly. If the likelihood that it equals, basically we're saying likelihood that it is 76 is 0.0008. That's the likelihood of this happening with mu equal to 76. So probably mu is greater than 76. How probably? 0.9992. So the way that we write that down is the following way. We are 0.9992 confident that mu is greater than 76. So that's how we write this down. Okay. So does that make sense? Yes, Tierno. We did, we just did norm S dist and we found the areas. Well, norm S dist gives you 0.9992 and then 1 minus gives you 0.0008. So all I'm showing you now, so again, final words, notice that all these calculations we did before, it's just a question of how do you write down your first step, HOH1, and how do you write down your last step, which is your conclusion. Okay.